Let's look at another example, ammonia molecule. The 3 hydrogen-nitrogen bonds act in the same direction towards the central, more electronegative nitrogen atom. The molecular dipole is equal to 1.47 dBs, which is slightly higher than the bond dipole of hydrogen-nitrogen. Let's look at this exercise. Which of these molecules are polar? For each that is polar, specify the direction of its dipole moment. Chloromethane, formaldehyde, and acetylene. First, let's draw the geometrical structure of chloromethane. Chloromethane has tetrahedral molecular geometry with 3 carbon-hydrogen dipole directions towards the carbon and the carbon-chlorine dipole towards the chlorine. The geometry makes the chloromethane polar compound. The molecular dipole direction is towards the chlorine atom, upwards. The measured dipole moment is equal to 1.87 dBs. Secondly, formaldehyde. Formaldehyde has a triagonal planar geometry. The 2 hydrogen-carbon dipole moments toward the carbon that add up to the dipole moment of the carbon-oxygen bond towards the more electronegative, which is oxygen. The molecule indicates that the molecule is polar with the direction of the dipole moment upwards towards the oxygen atom. Thirdly, acetylene. Acetylene is a symmetrical linear compound. There is no area on the compound that the charge is concentrated above it, which makes it non-polar compound with a net dipole equal to 0. Let's look at another example. Which molecules are polar? For each that is polar, specify the direction of its dipole moment. Dichloromethane, hydrogen cyanide, and hydrogen peroxide. First, dichloromethane has a triagonal pyramidal geometry. You have 2 hydrogen-carbon bonds pushing electron density towards the carbon and 2 carbon-chlorine atoms pulling electron density toward the 2 chlorine atoms. The net molecular dipole moment is equal to 1.67 dBs due to the geometry of the structure. With this molecular dipole, the molecule is polar with direction downwards. Second example, hydrogen cyanide. You have 2 bonds, hydrogen-carbon bond with dipole direction towards the carbon and the carbon-nitrogen triple bond with a dipole direction towards nitrogen. The molecule is polar with dipole moment direction to the right. Notice it is a linear molecule that the whole dipole adds to one direction towards the nitrogen. So you expect a large dipole value. Actually, the measured value is equal to 2.98 dBs. The third molecule, hydrogen peroxide, has 3 bonds. 2 hydrogen-oxygen bonds and 1 oxygen-oxygen bond. The molecule is polar with a molecular dipole equal to 2.2 dBs, with both hydrogen-oxygen bonds pushing electron density over the 2 oxygens, adding up to the oxygen-oxygen dipole moment. Although you may think the bond dipoles are cancelling each other, the bent shape of the hydrogen peroxide makes the atoms lie on different planes.